Hello everyone, and welcome back to a new video in programming the finite element method using MATLAB. Now we are starting to become technical here because we're going to be starting to talk about something called the local coordinate system as it is needed for the calculation of the stiffness matrix and then the transformation of that stiffness matrix from the local stiffness matrix into the global stiffness matrix. So this is going to be a little bit technical and I hope you enjoy. Now, if you are new to this video series, you would need, of course, to double check the playlist on the top right, which is basically about the finite element method. And if you're only interested in the programming aspects, then another playlist linked also on the top right is going to be talking about the programming only. Now, of course, as per usual, the code is going to be available to my dear channel members. But if you're not a channel member, then don't worry, because every single line of code that is available to my channel members is going to be written here live, so you can write along and follow, and you will have the exact same code like my dear channel members. So with that being said, and without further ado, sit back, relax, and enjoy the show. So now let's be technical a little bit. To be able to perform anything with the finite element method, like calculating the global axis, calculating the global stiffness, and transforming from the global to the local, we need something called the transformation matrix. And to be able to calculate the transformation matrix, I need to know the local coordinate system of an element. And the local coordinate system of an element is the local x-axis direction, the local y-axis direction, and the local z-axis direction, because using those I can construct the transformation matrix. Now, I talked about the local axis before in one of my videos in the finite element method series. We need to find the vectors by assuming how the vectors are. Now, let me explain to you exactly how my local axis is going to be for the member. The local x-axis is going to be the unit vector that connects the starting point of the element to the ending point of the element. The local y-axis is going to be a horizontal axis with orientation that shall be decided later. And the local z-axis is going to be the cross product of the x-axis and a horizontal y-axis. Finally, the y-axis is found by cross-producting the x and z-axis if need be, and this will be shown to you very soon. I say if need be because there are some special cases where we need to basically decide stuff for ourselves. Those special cases happen when the local x-axis is parallel to the z-axis, and we shall talk about this very soon. Now, to start implementing things, I need some properties here, so I call this the Vx property, which means the unit vector in the direction x. I also need Vy, which is the unit vector in direction y, and Vz, which is the unit vector in direction z. Those shall be calculated whenever I refresh the line, because those Vx and Vy depend on the nodes. So if I change the nodes, those must be recalculated. So here, I'm going to first of all ask it to apply or do a refresh function, and I need to define what the refresh function is. So the function here, refresh of object. Now this refresh of the object, you could also say calculate local axis if you want. I like to call it refresh. So what happens during the refresh? We need to calculate the local x-axis, y, and z, starting with the x-axis. Now the local x-axis is going to be node 2 minus node 1. Of course, node 2 has 3 coordinate components, and node 1 has also 3 coordinate components. So I must say node 2x minus node 1x, and node 2y minus node 1y, and node 2z minus node 1z. So I just do this and say node 2.object.node2.x minus object.node1.x. That is the x component of my Vx. Then object.node2.y minus object.node1.y. That is the y component of my Vx vector. And finally, object.node2 dot z minus object dot node1, dot z. This is the z component of my Vx. Now there's a problem with this. The problem with this is, first of all, I should call object dot so that it refers to the field or the property. And secondly, this is not normalized, so I can normalize it. Now, how do I normalize vectors? Allow me to show you. Let's say I have vector A, which is 3 in the x, 4 in the y, and 0 in the z. There is a function called norm in MATLAB. So let me show you what norm A is. If you say norm A, it gives you the length of A, which is basically the square root of sum of squares. You could have another A, which is 3, 4, 5, or 3, 4, 5 in the 3D. Then norm of A is going to give you the square root of sum of squares, which is basically the length, which is this one. You can also verify this by saying square root of sum of A times A transpose. This is the mathematical way of doing it, and you get the same answer. So here I need to normalize this, which means I need to take Vx, the new one, which means the new Vx is going to equal the old Vx divided by its length, which is norm of object.Vx, to normalize the vector Vx. Then I need to find Vy, and to find Vy, I must check, and the check is the line vertical? That's a question I need to ask. So how do I know if a line is vertical? If a line is vertical, then the Vx, the local system, the local x-axis system, is going to be straight up or straight down. And straight up or straight down means that the x component of Vx is 0, and that the y component of Vx is 0, and that the z component is the only component that exists. I can easily do this by making a check. So to check this, I can, for example, say if now the mathematics way of doing things is going to be object.Vx of 1, so the x component, is 0. But that's not the good way of doing things, because there might be numerical errors. Let me explain this to you very quickly. If you have a vector, let's say the vector here is, let me just put a comment here, Vx equals like 0i plus 2j plus 3k. This is not a vertical vector because it has components in the x or y. But if you have 0, 0 in x and y, then this is a vertical vector. Of course, it would need to be normalized, but so it makes 1 here, but it still stands. You would have nothing in x, nothing in y, and everything in z, positively or negatively. This needs to be checked. But the problem is, once again, due to numerical accuracy, you might have 0.001, and this will freak out the calculation. And this will cause a lot of problems. So what I will do is I will compare the value to the epsilon. I'm not going to say equals 0. I'm going to see if it's close to 0 or not. So how do I do that? Well, first of all, I need to define here my constant, which is the epsilon. So I say properties, and here, I think I can copy it from the node. I think I've done this before at the node. No, I've done this somewhere, or the controller. Let's check. I can even declare it as constant if I want, and I think that's the best way of doing things. So let's declare a constant here. So properties constant. And here I'm gonna define an epsilon again. And to stay consistent, I will take the same epsilon as the controller. You could have different epsilons, and that's the reason why I have multiple epsilons defined here and there, because you could have different accuracies at different conditions, but I will keep it the same. So now here, let's dive into it. Instead of saying object.Vx equals 0, I'm gonna ask, is the absolute value of the object.Vx, the first value, less than the epsilon, the strline.epsilon. So I'm asking, is it a small value? Okay. Now, if it is a small value, that's not enough to declare it to be parallel to z. We need to check both x and y. So here, that's not enough. I need to also check y. So I will say here and I will check the y. Let me copy this very quickly and check the y component of the vector. You know what? Let's ignore if it's going up or down. Let's treat them the same. So I'm just going to say this value is a little bit more than 0. So I'm going to ask here a question. Is the absolute of object.vx of 3, that's the z component, more than strline.epsilon? So there is a value. Okay, that's what I'm going to do. Oh, I must make this. So let's recap what this check is. This check checks if the line is parallel to the z-axis by checking if the x component is 0 and the y component is 0, but that's not enough, because the x component must be close to 0, the y component must be close to 0, and the z component must not be close to 0. That's why there's a more. Now, if that's the case, then we're going to have a special case. If that's not the case, then we have a regular case. So this here is a special case where the line is parallel to the z-axis. That's a special case. And this needs special treatment. Now, why do I need a special case treatment? Well, to understand this, I want to explain to you what happens if you don't have a special case. If you have a regular case, then the Vx is in the direction of the line, Vy is going to be a horizontal vector, and Vz is going to be the vector from Vx cross Vy. Let me write this here. So Vx is from start to end, and Vy is a horizontal vector, and Vz is going to equal Vx cross Vy. However, I don't have Vy to find Vz. I only know that Vy is horizontal. So to find Vy, I can make Vz temp, or I can just say Vz and declare it to be 0 and 0 and 1. That is a perfectly vertical vector. And now I can cross product Vx, which I know, with Vz, the temp one. Because I want Vy to be horizontal, I will say here object dot Vy is going to equal cross. Now, by the way, MATLAB has a cool cross product feature. Let me show you. Like if we say, for example, a 3-dimensional vector, A equals 3, 4, and 1, and B equals 1, 2, 3, then you can ask a cross product, and it asks you, of course, for vector 1 and vector 2. So I can say, for example, A cross B, and it will give you the cross product value. You can even double check that. For example, let's say I will have A, which is a 2-dimensional vector, 1 and 2, and B is a 2-dimensional vector, which is 3 and 4. Then you can easily cross product them. I think it's the this times this minus this times this, I think. So I expect the answer to be -1. Let's try that. Cross A and B, and the answer is, it's calculating, it seems. Oh, it wants 3D. Okay, fine. Let's try this again. So A is going to be 1, 2, and 0 in the Z. And B is going to be 3, 4, and 0 in the Z. Just 0 in the Z because I want to be able to brain calculate it. Now, if I cross product A cross B, so let's repeat that, cross, and let's just choose cross A and B. Yeah, -2 in the Z. Perfect. Because how it does it, it will say I cross I is nothing. And then I cross J is +4K. And then J cross I is -6K, so -2. And then J cross J is 0. So that's why I get a -2. This is how the cross product works. Just cross and the vector A and the vector B. So now here I can get Vy by crossing the Z times X. In mathematics, if you want to find the Y, then you cross Z times X. Because if you cross X times Z, you get -Y. This is mathematics. So here I'm going to cross the object.vx, sorry, not Vx. I'm going to cross this Vz and the object.vx. This will give me the object.vy, but that's not enough because I need to normalize it. So I'm going to say object.vy equals object.vy divided by normal of object.vy. And I think this should be that. And finally, I can find the real Vz now. I can find the real one by crossing X and Y. This is a dummy one to facilitate the Vy being horizontal. Now that we are done with this, I want to find the Vz, the real one, by cross-producting So I'm going to say object.vz equals the cross product. This is a very annoying video, by the way. Cross product of x and y. I cannot do this. I must say object, right? Object.vx and object.vy. That's not enough. Now, by the way, this should be normalized anyway, but I like to be extra careful and basically normalize it myself. So object.vz divided by the norm of object.vz. I think that's that. So this is how it looks if I don't have a special case. If I have a special case, things change. Why? Because if I simply copy-paste this, this won't work, and specifically, this is your culprit. Why doesn't it work? Because that's a special case. You are going to declare vz to be this, and then you are going to cross-product vx with vz. Now, there's a problem. Vx is parallel to vz, parallel to the z-axis. So Vx is parallel to this vector. And if I cross-product parallel stuff, I get zero, I get nothing. So that's the reason why the special case needs to be dealt with. Just because we declare a temp, it doesn't work here. So this entire thing won't work. What would work is to assume Vy first as a helper value, and even just keep it, by the way. I can assume Vy directly. So object.Vy as a special case is going to equal 0, 1, 0. So this is perfectly in the y-axis. And then I can calculate the Vz by cross-producting this. I declared Vy by hand because I know that I cannot cross-product it. And I already know that if an element is parallel to z, then the y-axis is going to be in the global y-axis. The local y-axis is going to be in the global y-axis. That's the reason why I'm doing this calculation. So this basically calculates something called the local coordinate systems of elements. And yeah, I think we have done once again a good job in doing something in this video. This is a rather technical video, so you need to have a good grasp of the finite element method. If you don't, then there is a playlist that will help you brush up your abilities. I linked it in the beginning of the video. But well, that's everything I wanted to talk about today. I hope you enjoyed. And in the end, I want to give a local axis-sized shout-out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support to the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.